Concrete. It is one of the most common building materials of this time. It is used in almost every building and construction we see nowadays. Walls, slabs, bridges, prefabricated parts such as stairs. The areas of application are huge and the possibilities are almost unlimited. The basic ingredients are always the same: cement, water, stone, and additives. Depending on the mixing ratio, the right concrete can be produced for every purpose it has to serve. Modern-day society demands more and more sophisticated constructions and therefore also a continuous development of building materials. For bridges with spans of several hundred meters, tunnels through the highest mountains, and skyscrapers with 200 and more floors, it is of course not possible to build with normal strength concrete, but requires very precise calculation and adaptation to the given circumstances. Starting from the common reinforced concrete, several special concretes were developed, which created new possibilities for building higher, better, stronger. Today, I would like to give you a brief insight into some of these special concretes. Examples are self-compacting concrete for exposed concrete surfaces and complex shapes. High-strength concrete for skyscrapers, towers, and bridges. Lightweight concrete for prefabricated parts and extensions of existing buildings. Sprayed concrete for tunnel constructions. Fiber concrete for roadways and heavy-duty industrial floors. But what exactly makes these concretes so special? What makes them so strong, or light, or waterproof? The secret lies largely in the additives and admixtures. While powdery natural additives are added to the base mix in larger amounts, liquid chemical additives are added in very small amounts, but with even greater effect. Additives include stone flours and pozzolana, which influence the final compressive strength and processability. Admixtures are a wide variety of chemicals. Their use can influence the flow behavior, the hardening speed, the air void content, and a lot more. This knowledge is used to create exactly the right concrete for the job. In order not to go beyond the scope of this video, I would just like to introduce the idea of self-compacting concrete to you. To develop its full load-bearing capacity, concrete must be compacted after being poured into the formwork. In the case of complex cross-sections, or if the building component is to be designed as an exposed concrete surface, this can lead to problems with common concrete. These issues can be solved with self-compacting concrete. The concrete mass has to be just fluid enough so that the formwork will be perfectly filled, but viscous enough so that the aggregate inside the mass does not sink. It compacts and vents by gravity alone. To achieve this state, it requires a combination of multiple things: an increased flour grain content, which leads to a more compact concrete matrix, a stabilizer like fly ash to make the concrete mass more viscous, and a highly effective superplasticizer to reduce the surface tension and allow good distribution of all components. This recipe must be calculated very accurately, otherwise there's the risk that the aggregate will sink to the bottom of the formwork, or the concrete will separate. Because of the high amount of calculation, post-processing, and the increased material cost, it makes self-compacting concrete relatively expensive. However, the final result is impressive. The best quality of exposed concrete, a high homogeneity of the concrete, and a very easy concreting process. I thank you very much for your attention and hope you enjoyed the video.